we have seen with what is Newton's law. Now we are going to see with the discussion on Newton's law. So what are the positives and how all we can do with this Newton's law. Okay, so first, the Newton's law are called as a vector laws. The Newton's laws are the vector laws, and we are taking with the Newton's second law, which is F is equal to m into a. This is a vector equation, and it is equal to 3 scalar equations. Okay, so how we are writing with the scalar equation, let us just see it now. But with one form of vector, we are able to write with 3 scalar. So how we are writing that 3 scalar is in terms of Cartesian coordinates. So what are the Cartesian coordinates we are going to take is which are said to be x, y and z. So these are the Cartesian coordinates. So x, we are considering it as I, y it is j, and z we are writing it as k. Okay, so this is how we will be writing in the next step. So we are taking with the same equation, F is equal to m into a, that we are going to write in the scalar equations as. So we are writing this f of x into I. As I have told you, whenever you get with the term x, we will be writing it as I. Then y, it will be written as j, and z will be writing it as k. Okay, and as we know, the general equation is what? F is equal to m into a, is it not? Now, instead of this f of x, we are writing it max. Then f of y, it is may. F of z, it is maz. Okay, now by comparing on both the sides, we know that just we compare with the components of I, j and k. So both the sides, if you see with the value of I, okay, so this is I, same way this is also I. Okay, so we are comparing this, we are writing as f of x is equal to m into ax. So acceleration along the x direction depends only on the component of force which is acting along the x direction. So if you consider the acceleration along the x direction, then the force also along the x direction. Next is when you compare this j, f of y is equal to m into ay. Okay, same way, when you consider acceleration along the y direction, then the force also acts along the y direction. Okay, next is k, f of z, which is equal to m into az. Okay, so here also acceleration, if it is along the z direction, then the force is also acting along the z direction. Okay, so this is about the first point. So first point is what? The Newton's laws are vector laws. So vector la denote pannalam அப்படின்றது first one. Okay, then the second one is the acceleration can be expressed by the time taken. Okay, and it depends on the force which acts on the body at that instant of time, and it does not depend on the force which is acted before the time t. So if suppose this is an object, you are giving the force F. ஸோ அந்த டைமில் என்ன ஃபோர்ஸ் இருக்கோ அதை மட்டும்தான் டிபெண்ட் பண்ணியிருக்குமே தவிர கொஞ்ச நேரத்துக்கு முன்னாடி இல்லை கொஞ்ச நேரத்துக்கு முன்னாடி பிஃபோர் த டைம் வாட் இஸ் அ ஃபோர்ஸ் that it does not depend. Okay, so the acceleration depends only on the force which acts on the body at that instant of time. அந்த டைமில் எதுவோ அதை வச்சு தான் டிபெண்ட் பண்ணியிருக்குமே தவிர அதுக்கு முன்னாடி இருக்கிற ஃபோர்ஸ் வச்சு டிபெண்ட் பண்ணி இருக்காது. ஸோ ஜென்ரல் ஈக்குவேஷன் இஸ் வாட்? F is equal to m into a. This I am also writing in terms of t because t is a time taken. Okay, this is the second one. Yes, then the next one is we have the third point. The third point is the direction of force may be different from the direction of motion. Okay, so what is the third one is the direction of force different from the direction of motion. So it's not that both the force and the moving will be in the same direction அப்படின்றது இல்லை. They can be in the different direction. Though in some cases the object may move in the same direction. Some cases it may move, but it is not always true. We have also some examples based on this, the direction of force and the direction of motion. Okay, so first we have the force and motion are in the same direction. So for this, the example is when an apple falls towards the earth. Okay, the direction of apple and the direction of force are in the downward direction. If you know that, just here the apple falls down, so here is the direction of motion. Same way, how the direction of force is, the direction of force is also downward, so both are in the same direction. So force and motion are in the same direction. Okay, so this is a first one. Okay, then next one we have the force and motion when they are not in the same direction. So not in the same direction is, this is a moon and this is the earth. Okay, this is the direction of force. Okay, between the moon and the earth there is a force, is it not? So this is the direction of force, but how the moon moves, the moon is moving in the other direction, is it not? So direction of force and the motion are not in the same direction, they are not in the same direction. This is a second example. Okay, then the third one we have, if they are in the opposite direction. So this is an example, force and motion are in the opposite direction. For this, let us consider that an object is thrown up. When you are throwing an object up, will it move in the same direction? No. After going up, what happens? It comes down, is it not? So here is the direction of motion and here is the direction of force. So because of force, what happens? Because of the gravitational force, it comes down. So the force and motion are in the opposite direction. Okay, so this is the third point, force and motion are in the opposite direction. Okay, so these are the 3 points. Next we are going to see with the fourth one, that is zero net force but there is motion. Okay, so there is no force, force illa, ஆனால் என்ன இருக்குது, மூமெண்ட் மட்டும் இருக்குது. There is a motion but there is zero net force. So how it is when the raindrops get detached from the cloud. So this is a raindrop, so this is falling from the cloud to the earth. What happens is it experiences both gravitational force and upward drag force. So when it is coming down like this, what it experience, கீழே ஒரு gravitational force இருக்குமா? ஓகே, ஸோ கீழே ஒரு கிராவிடேஷ்னல் ஃபோர்ஸும் மேலே ஒரு ஃபோர்ஸ் இருக்கும், அதுக்கு பேர் என்ன சொல்கிறாங்கன்னா அப்வர்ட் ட்ராக் ஃபோர்ஸ் அப்படின்னு சொல்கிறாங்க. ஓகே, ஸோ கீழே ஒரு கிராவிடேஷ்னல் ஃபோர்ஸ், மேலே ஒரு அப்வர்ட் ஃபோர்ஸ், அப்வர்ட் ட்ராக் ஃபோர்ஸ். ஆஸ் இட் டிசென்ட்ஸ் டுவர்ட்ஸ் தி எர்த், த அப்வர்ட் ட்ராக் ஃபோர்ஸ் increases and attains and after certain time the upward drag force cancels the downward gravity. So என்ன ஆகும் அப்படின்னு பார்த்தீங்கன்னா, இந்த மாதிரி ட்ராப் கீழே வந்துகிட்டே இருக்கும்போது இந்த அப்வர்ட் ட்ராக் ஃபோர்ஸ் என்னாகும், இன்க்ரீஸ் ஆகிட்டே இருக்கும். ஒரு டைமில் இந்த அப்வர்ட் ட்ராக் ஃபோர்ஸும் கிராவிட்டியும் என்ன ஆகும், கேன்சல்ஸ். ஓகே, இட் பிகம்ஸ் கேன்சல் ஆகிடும். அப்போது அந்த ட்ராப்க்கு என்ன ஃபோர்ஸ் இருக்கும், ஒரு ஃபோர்ஸுமே இருக்காது. நம்ம ஆல்ரெடி என்ன சொல்லுவோம், 2 ஃபோர்ஸ் இருக்குன்னு சொன்னோம், கிராவிடேஷனல் ஃபோர்ஸும் அப்வர்ட் ட்ராக் ஃபோர்ஸும். ஆனால் ஒரு டைமில் என்ன ஆகுது, அது ரெண்டும் கேன்சல் ஆகிடுது. கேன்சல் ஆனோன்னு என்ன இருக்கும், அதுக்கு ஃபோர்ஸே இருக்காது. ஓகே, ஹென்ஸ் த raindrops comes with a zero net force, ஃபோர்ஸே இல்லாமல் அது வந்து கீழே வரும். So that is the example for zero net force but there is a motion. Okay, so clear with this example? Yes, so we are also given with a diagram here. So this is a diagram, the upward air drag and downward gravity. So as it moves on, what happens, the air drag increases and so it becomes cancel. Okay, the fourth point is, if multiple of forces, if you are considering more than one forces, that forces are written as F1, F2, F3 etc. up to Fn, then they all act on the same body. So we are considering only one object. So in this object, if there are more forces acting on this, then the net equivalent force is the sum of the individual forces. So this force is equal to sum of all this. So we are writing as f of net, which is equal to F1 plus F2 plus F3 plus etc. up to Fn. Okay, so the net force is equal to the sum of all the individual forces. Okay, so this is the fourth one. We have the diagram for this. Suppose if you have the two vectors, okay, and this vector A is the addition of this both, so we can write this as C plus B, or this can be written as A plus B, because one or more forces, if they are acting, it is equal to the sum of all the forces, is it not? So because of that we are writing like this. Next we have the fifth point. The fifth point is we are writing with the Newton's second law. So what is Newton's second law? It is F is equal to m into A, is it not? So F, which is equal to m into A. Now instead of this A, I am going to write it as d square r by dt square. So how we are writing with this d square r by dt square is, we know that acceleration is equal to what? Velocity by time taken, is it not? Now this can also be written as rate of change of velocity by time taken, so dv by dt. So this is a general representation of acceleration. Now what is the formula for velocity? Is velocity is equal to distance divided by time taken. Now this can also be written as dr divided by dt அப்படினு எழுதலாமா? Okay, now substitute this value of v in this place. Okay, so you'll be getting as A, which is equal to d divided by dt, d divided by dt as it is, but instead of v I'm going to write with this term, so you'll be getting as into dr divided by dt. Okay, now this d into d, that becomes as d square, r as it is, dt into dt, that becomes as dt square. Okay, so this is the other form of writing with a Newton's second law. So what is the other form? Is F is equal to m into d square r divided by dt square. Okay, so this is a one more equation, that is F is equal to m into d square r by dt square. Yes, next we have the sixth point. The sixth point is, if we consider with no force which acts on a body, then the second law can be written as, so no force means what? F is equal to 0, is it not? So F is equal to 0 means, what is the formula for F is equal to m into A. Just now I told you that A can be written as what? dv by dt. So they are writing this here, so dv divided by dt. So this will be equal to 0. If this is equal to 0, this term comes here. Okay, so we get dv divided by dt is equal to 0 அப்படின்னு கிடைக்குமா? ஓகே, ஸோ எந்த டேர்ம் டிஃப்ரென்ஷியேட் பண்ணால் நம்மளுக்கு 0 கிடைக்குமோ அந்த டேர்ம் பேர் என்னது? தட் இஸ் ஈக்குவல் டு கான்ஸ்டன்ட் அப்படின்னு சொல்லலாம். ஓகே, ஸோ வி ஆர் ரைட்டிங் தட் v இஸ் ஈக்குவல் டு கான்ஸ்டன்ட். ஓகே, ஸோ திஸ் இஸ் நியூட்டன்ஸ் ஃபர்ஸ்ட் லா அப்படின்னு சொல்கிறாங்க. Because when you differentiate, that becomes constant, that is Newton's first law. So second law la enna derive பண்ணிட்டோம், நம்ம first law derive பண்ணிட்டோம். Okay, so when there is no force acts on a body, then the velocity remains constant. So reduction of second law is to the first law. Second law is being reduced to first law. Okay, so this is the main point, because the second law has been reduced to what? First law, when there is no force acting on the body. Okay, so this is a sixth point. So next we have the seventh point. Seventh point is, Newton's second law is also called as a cause and effect relation. So it is called as a cause and effect. If force is a cause, acceleration is the effect. Okay, so when this is written, this we are writing as F is equal to m into A. Instead of this ma, we can also write as F is equal to dp by dt, because as I have told you, there are two equations for Newton's second law. Okay, thank you.